Katie has Katie has reminded me that I've forgotten to record, so sorry. We'll we'll be missing a little bit about some of the computer stuff, but I imagine reading that isn't terribly hard. Um, if you
Um,
want me to go back and repeat anything, I can definitely do that. But
so Michael,
let me
have
know.
one question here.
Yes.
Yes, this is Jihan.
Hmm.
So you said that the T-Course 1 has a 64 AMD cores, but then each core has some multiple processors, right?
Right. So a strange thing about most modern processors now is that in the operating system, they'll show up as two actual processors, and it's because they do a thing called uh, in Intel's case, hyperthreading. In AMD's case, simultaneous multi-threading, I think. It basically means that the processor has enough power at its disposal to kind of act like two, like any given core has enough power at its disposal to act like two cores for some applications. And that's kind of a tricky thing in terms of performance because there are some cases where if you treat that processor as having, so say you treat the 64 core processor as having 128 cores, you're going to get performance that looks pretty close to what you'd expect from an actual 128 core processor. But there's
Mhm.
other applications where you don't get that kind of speed up. So in situations like that, and basically with all of these systems, what I tend to recommend is when you're scaling your analysis, test it out a little bit to see if it seems to actually take advantage of that. One thing you can do is start by loading all of the physical cores, so create, say, 64 processes and see how long that takes, and then load the system with more than 64 processes and see if you get see how linear your improvement
Mhm.
in runtime is.
Yeah, because the reason I asked you is that I used to actually run like 100 processors
Hmm.
at the same time in the T-Course 1, and I didn't, yeah, think that there was only 64 cores.
Yeah, it's that is quite confusing about modern processors, and I still have not worked out a really solid kind of logic for when an application is going to take advantage of the hyper-threaded cores and when it's not.
I see.
So it's it kind of comes down to just sort of guess
Mm-hmm.
and check to see if you have an analysis that takes advantage of that well.
Mm-hmm.
And
Mm-hmm. Okay.
similarly, T-Cores 03 is going to show up as having 256 cores because it also has essentially hyper-threading.
Yeah, that's right. Okay, thank you.
Yeah, no problem. Speaking of, if you have questions during this workshop, please just go ahead and say them whenever, and I can try and get to that. I don't think we're likely to be terribly pressed for time here. So back to T-Cores 2, the reason that this system happened is because not every analysis that people are likely to run may need the number of cores that are available on T-Cores 1 and T-Cores 3. There are some things that just don't need to scale that much because whatever you're running can't or just isn't that big. And one of the trade-offs in computer processors tends to be that the more cores you cram into a processor, for one, the hotter that thing gets, but also it can't run at the same speed as a sort of as a processor that's less dense. Like a chip that has 8 cores can dissipate the heat from those 8 cores running at a much higher speed than something about the same size that's got maybe 16 cores in it. So T-Cores 2 was designed to be a system that can do less parallel work faster because those 8 cores are running at a much higher speed than the 64 or 128 cores in T-Cores 1 and T-Cores 3. And this system tends to be, Raphael had requested that this system have somewhat more restricted usage because it, in part because it only has 8 cores, it can't support as many simultaneous users. So um, this is really largely for testing, but also for kind of more specific cases where somebody has an analysis that maybe only needs 2 cores, but you need those to be fast cores. So these are the resources available in-house, and in a little bit, I'll talk about how to actually access them. One of the things that I think is maybe going to be different in terms of working with these systems versus working with some of the other remote resources at the university is that they do not have any kind of graphical remote desktop feature. So there's not sort of a virtual sites equivalent. So when you interact with these systems, it's going to be purely through that uh, matrix style terminal. There are a few options to access the CAsToR systems remotely. The primary one that I'll talk about first, or the one that I'm most used to working with, is called Secure Shell Hosting, or SSH. If you've worked with high performance clusters and things before, like Flux, you've almost certainly used SSH to access them. So all this does is creates a secure direct connection to the system, gives you a terminal interface, and one nice thing about SSH is that you don't need to be either directly connected to a university network, say on campus, or you also don't need to use the U of M VPN because our IT considers SSH to be secure enough to allow outside of the university, where some other remote connection methods do actually need the VPN. The alternate method, and this is kind of where I feel like the future is in some ways, and this still feels futuristic to me, is using RStudio server's client interface, which, just kind of to preview, RStudio server from the client end is actually browser based. So right here, this is just a Chrome tab, and once you log in, which I'll demo a bit later, you're you're just into the system, and you can use RStudio. You also can interact with the system through a built-in terminal. You can transfer files. It's very cool. Even though I am not myself an R programmer and I don't particularly like R, this is a great system. Um, you do need to be either on an on-campus network or connected to the U of M VPN to access this because it's communicating on a different port and it doesn't have the same security measures in place. I'm working on some of that, but part of it is just the port communication. So first off, to connect via SSH, there's a bunch of different ways to do this depending on your platform. So a lot of operating systems will have a built-in SSH client. If you're on Mac, or if you're on a Linux system, I mean, if you're on a Linux system, then this entire workshop might not be entirely necessary for you. Then you have a built-in SSH client. As of fairly recently, some Windows 10 builds, I think it's the basically any reasonably new one will have a built-in SSH client, but I haven't tested this in a while, so your mileage may vary on that particular thing. But if you are on a Mac or a Linux system, then SSH is super easy. You open a terminal and you enter this command, SSH, your username at the host address, and you're in. One thing to note, if you're coming from a Mac, something that I think is helpful in working between Macs and Linux systems is that under the hood, Mac OS is a Unix operating system. It's fancy and pretty now, but if you open a Mac terminal, that's basically a Unix terminal. It has a shell environment very much like the shell on a Linux system. You can use many of the same commands, a lot of the same tools, and that can be really powerful. It's part of why in some cases, I will prefer to work from a Mac system if I know that I want a certain amount of Unix-like functionality. Um, these are the addresses for the three CAsToR systems here. So UMT cores 01.ddns.sph.umich.edu and so on. So when you're SSHing into a system, you'll want to, if you're using one of the terminal interfaces, you type something like ssh umt cores 01.ddns.sph.umich.edu. And that will do the thing. One thing that I will note about this that's actually quite cool that I don't think is terribly widely advertised is that SPH has what's called a dynamic domain name system. And that means that normally, kind of in the old school style of things, if you wanted to SSH into a computer, if you wanted to talk to a remote computer, you'd have to put in its IP address, which is that like 191.168.1.0.0 thing, which identifies a computer to to outside applications. And that's for one. I find those hard to remember, but also those can change if your routing infrastructure reassigns the IP address to a computer. A lot of home routers do this, so your home laptop is likely it likely has an IP address that changes maybe every 6 months or something like that, and that's kind of a problem if you need a consistent location to access a computer. A dynamic domain name system basically lets you access those systems by a convenient alias instead of its exact IP address. So that's why you can access the TCore systems using these names, which I find much more convenient to remember than a numerical IP address. And even if the underlying IP address of the system changes, you can still access it by this domain name. And this works for pretty much any computer connected to the SPH network. So if, for example, you were to set up a Mac and plug it into the U of M network, and you've named your Mac, um, I don't know, Keyboard Fiasco or something like that, then you could actually remote into that laptop with the address keyboardfiasco.ddns.sph.umich.edu, which I think is actually a really nice feature. Um, and saves a lot of hassle. So if you don't want to use one of the built-in SSH clients in your operating system, there are a bunch of third-party options. In Windows, traditionally the option that people will use is an application called PuTTY. I used that for years. WinSCP is also a platform. WinSCP is a nice platform because it also lets you do file transfers. I've tried out Bitvice a bit. They're all fine. Lately, I've actually been using a multi-platform browser-based SSH client because um, I find that browser-based clients are nice because if I'm switching between systems, I don't have to worry about whether that computer has the right software installed or not. It turns out that the Chrome browser has an SSH extension, so hopefully you can see this tab now, which is Chrome's built-in um, SSH client. It's surprisingly powerful and really surprisingly user friendly. If you want to access it when you can open a new tab and then type SSH and it will, if you have the extension installed, you may need to install it, but I'm not actually certain that I did, and now I have access to it. So test that. If you need to install the extension, install the extension. I generally recommend this client, but it kind of magically takes you to Chrome's SSH client, which you can then so in this case, I've put in tcores 01's address. This bit here is just a name. You enter your system name, so tcores 01. You can enter your username. So I'm going to log in as me, and then I've put in the system address. You can pass extra arguments to SSH. SSH allows a number of different configuration options, but for the moment we can just connect as normal. You'll want to enter your port, so SSH communicates over port 22, and that will just always be the case. And then you hit connect, and if you're connecting for the first time, the system will prompt you to accept the connection's keys. You'll just type yes, hit enter, and then I'm in. And now I'm looking at the terminal interface for tcores 01. And at this point, I'm going to kind of pause for a moment because I should have, if I did everything right, I should have made an account for everybody who signed up for the workshop on tcores 1. So I was hoping that you could all test connecting to tcores 1 using your favorite SSH client. I've made your username your unique name, unless I misspelt it. I think I misspelt June's, and I'm very sorry about that. Um, and your password for now is change me, which I would like you to do as soon as you log in. So first off, if you could try logging in, if you have an SSH client installed, fantastic, use that. If you're on a Mac, I would encourage you to use the built-in terminal SSH client. If you're on Windows, if you're on a new build, what you might try is opening PowerShell and checking to see if you have an SSH client. So I'm going to I'm going to stop sharing and then see if I can't share my PowerShell terminal just to demonstrate what this is going to look like. Oh, look, it does. Okay. This could be because I've installed this on my system at some point. I can't remember whether I'd configured this one, but if you're able to do this, it will look similar. I tend to prefer, also, I guess, as a note, I will pause this share and go back to the main window now. Windows has two terminal interfaces. The one that most people are familiar with, I think, is the command prompt, which is that dreadfully old school thing. But it also has a slightly more friendly terminal interface called PowerShell, which is what I would generally encourage you to use if you tend to work on Windows in a command line fashion. Its syntax just tends to be a little bit more Unix-like, and so it's easier to work between systems. So I will give you a bit to try logging in. Oh, I see that Buki has joined. I had not made you an account because I don't think that I had you on my list of folks. So if you wouldn't mind typing your unique name in the Zoom group chat, then I'll create an account for you on one of our TCore systems. What I've been doing right now is having folks test logging in just to make sure that all of that's working. So as you try logging in, I'm gonna try out a Zoom thing that I haven't really played with before. I guess give me a thumbs up or a yes if it works, or a thumbs down or a no if you have a problem, and or you can stick your problem in chat or yell at me because I didn't make your account right. Looks like June got it. Great. That was kind of a softball because she's been using these systems for
Right.
a little while.
So I think probably people also should first find out like what basically shell or terminal they have to use, right?
That would be a good idea. Yeah, actually, uh, I, oh, perfect. Thanks, Katie. So I will get an account built there. So I've been operating under the assumption that that most folks are connecting from Windows or Mac. So I guess first off, is anyone having any particular trouble accessing their SSH client or installing one if they needed to install one? This is a very quiet workshop group.
It's really hard without seeing each other, basically.
It is.
Michael?
Yes.
This is David. So I access SSH from my PC, but it just when I try to go to the TCourse 01, it says it can not resolve the host name. tcores01 ddns sph umichi.edu.
Just in case they're UMT cores 01,
Oh, UMT
the
course
address as
01,
here.
sorry.
Yes, sorry, I'll leave this up so that the addresses are available for everyone. And let me, I think I enabled screen share for participants. So if anyone is having a problem, stick a message in chat and I will stop sharing. Maybe we can share your screen and we can see if there's an issue. Let's see. So.
And then everyone has their own username, right?
That's correct, yes. So everyone should be able to log in with their unique name as their username.
Okay.
Yes, Sarah, I did make yours Sirius Cole. So let's see. So 3 is on Mac. Would you mind sharing your screen? Don't want to put you on the spot, but I think this will actually be this might be helpful for other folks.
Yeah. One sec.
Okay.
So can you allow me to share my screen?
You should be able to. I set it to allow participants to share. Is it not available?
Yeah.
It says that host disabled the attendee screen
Really?
sharing. So someone who is a host for this meeting have to allow.
That's a bit strange. I have allow participants to. Oh, there we go. Got it. I just can't read. That's the problem.
Okay, yeah, I see. So let me try to share. Here's my terminal.
And while you do that, I'm going to make an account for Buki real quick.
Okay.
Okay.
Yeah.
Okay, so what you're going to want to put in for the host name is umtcores01.ddns.sph.umich.edu.
So this one?
So yeah, where you've got umtcores01. After that, you want .ddns and then .sph. So it should look. Let me actually put this in chat.
Yeah, great.
There we go. Yeah, it's just slightly longer, I think, than one might assume.
Yeah, let me see.
Oops.
Okay, and then no, this one not.
So you're still missing .ddns.
Yeah, I
there.
see. So here .ddns. Okay.
And then before that, you can put SSH and space.
Ah, yes.
Yeah.
Your username.
And
right.
This one? Yeah. Okay.
All right.
And then you want to say yes.
So maybe I can access to the system right now, right?
Yep, you're in. So if what you're seeing is your username at umtcores01, then you have successfully connected.
So how to change the password?
Right, so I'm going to, if you would stop sharing your screen, I'm going to share mine again, and
Yeah.
I can put up the slide
Great.
that has the password.
Thank you.
Let's see. PowerShell, but no password. That is interesting. Would you like to share your screen then? I'm curious what you're seeing.
I just got in. Yeah, never mind.
Oh, okay, perfect, cool.
Yeah,
Yeah, sorry, PowerShell is the platform I'm actually least familiar with doing this on because I usually use a different client on Windows. Okay, so there is this. I'll put my screen back up, and here we go. Okay, so once you're in, all you have to do to change your password is type this command here, passwd, hit enter, and the system will prompt you for your current password, which is that, and then you can enter a new password. I would recommend writing your password down somewhere because even as an administrator, I cannot see your passwords. So if you do forget it, then I have to reset it, which is not hard, but then it takes time, and that's time that you're not able to access the system, which is a bit of a bummer. Can I get a few more check marks for folks that did successfully log in? I kind of want to get a sense for how this is going.
Okay, Sarah and Stephen, David, Akash. Yeah, they could log in.
Okay, and we know that Thui did.
Yes.
Let's see, so, and we know that Yunseo did. So Jiala, Evelyn, and Luis and Buki, have you had any issues connecting or oh, okay, Luis is in. Great.
System, but we cannot write the password. I don't know. Yeah.
I'm sorry, what was that?
But I cannot write the password.
When you're logging in, or?
Share my screen quickly.
When you're, to change your password or to log in?
Can I share very quickly the screen?
Yes, absolutely. Let me, actually, I'll just stop. There we go. Okay. Oh, I see.
I cannot write here.
Oh, okay, yes. So this is a funny thing about logging into Unix systems. When you're typing your password here, you're actually typing your password, but it doesn't show you anything.
Okay. Okay.
Yeah. I assume that this is a security feature so that if someone were looking over your shoulder, they wouldn't even know how many characters are in your password. So what I would try is just backspace a bunch to make sure that you've cleared anything out that you might have entered, then try typing your password in and then hit enter and see if it goes. And if it doesn't, then there probably were some leftover characters and I would just try it again.
Thank you.
Okay, so that sounds as though we have nearly everybody able to log in, which is great. Okay. So Buki, would you like to share your screen and we can kind of take a look at where you're at? Or if you have a more specific question for chat, then we can try to adjust that there.
Can you hear me? Can
Yes,
you hear me? Can you hear me? Okay. I don't even know where to start. Like, is this the
I
enclave?
see.
I don't know where to. Yeah.
Okay,
This is what you
so
want to do.
why don't I back up a little bit, because uh, I think I was sort of partway through when you joined. So what we're doing right now is accessing one of the TCore systems that I've set up remotely. So the first thing to identify is we're going to connect using a method called SSH. And the way that you do that depends on the operating system you're coming from. So if you're on a Mac, what I would recommend doing is opening a terminal, because there's a built-in SSH client program that you can access through the terminal. If you're on Windows, I believe you can use the SSH client that hopefully now is built into Windows using PowerShell or the command prompt, and I can walk you through either of those.
I'm using the
Are you on
Windows
a
10.
Windows 10? Okay, so what I would try is, do you know how to access the PowerShell terminal?
No.
So I would hit Windows, type PowerShell, and it should come up in your search thing.
Okay. Also. Yeah, I've seen it.
Cool. Open that up, and it should give you like a blue terminal window.
Yeah. Yeah.
Okay, perfect. And then in that window, let me see if I can share mine, and that might help. Application, PowerShell. Is that, scaling that just makes it bigger. Let me make the text size a little bigger so this is a little easier to work with. Okay, so what you're seeing is something kind of like this, right?
Yeah.
Okay.
User TSC :users, then my username.
Cool, perfect. So what I would try first is, so type just SSH with nothing after it. And if you get this, if it says this thing that's like usage SSH, that means that you have your SSH client installed, and it's baked
Yes,
in.
I did get that.
Oh, perfect. Okay, so the next thing you'll want to do is log in specifically to TCores 01. So I made you an account on TCores 01 using, hang on, let me go back to this. And where did I put it? Here we go. So your account username is your unique name. So that was, oh, well, I don't need to tell you your own unique name. And your password for the first time login is just going to be change me, no caps or anything. And so what you're going to want to do is I'm going to switch my, I assume there's a better way to do this, but I haven't figured it out. So we're going to do it kind of the dumb way. So you're going to type SSH. I'm going to put my unique name in this case. So your username at, and then the system address. So tcores01.ddns.sph.umich.edu, and then hit enter, and it will probably say something like, warning, permanently added this address to the list of known hosts, or are you sure you want to continue connecting, yes or no? Type yes, and hit enter.
Oh, yes.
Cool. And then it'll ask you to put your password in. And when you type your password, it's not going to show you anything. It's not going to look like it's doing anything.
So change me.
So type that, hit enter, and you should see something like this now with a green prompt with your unique name at UMTCores01.
Yep, I see that.
Great, nice, perfect. All right, so that, I think then, is everybody in. Sorry about that. I should have gone back a little ways.
No, you have come in late. Thank you.
All right, then let us get on to changing our passwords because those are the least secure passwords on the face of the earth, and it would be nice to have something better. So now that everybody's in, you can change your password using this command, passwd. Should be able to do that with user permissions. And so again, as you do that, unless you already have reset your password to something actual and more secure, give me a yes, green check mark, or a thumbs up once you're able to do that. Or I guess just tell me. I know some of this is likely to be a little bit excruciating, but hopefully it's helpful if you're not coming from working with a system like this. Let's see, so Buki, David, Akash, and Stephen are good. Yun Seo, and I'm pretty sure that I made Tui and Jiala accounts on and Jiyun accounts on this machine already, so you should be good to go with whatever password I made you before, and hopefully you've changed that at some point. If you haven't, then your password is still probably change me, and I would do that now. Great. Has anyone not managed to change their password who needed to? Looked like Louise, were you able to change the thing?
I'm not sure.
Okay.
Let me 1 minute.
Okay. So in the terminal, it should have just looked like this. And then it'll do that. I'm not actually going to change mine. I would put in my current password if I wanted to. And again, this is, you won't see anything changing here. Like you won't be able to see what you're typing through this because that's how these systems do that thing. So it won't look like you're typing anything, but you almost certainly are actually. I'm not actually going to change my password because that would be I would just forget it. Did it end up working? Sorry, I didn't quite catch that.
I think that I have an error with my unique name. So because it says that the permission is denied. So perhaps I will.
Here, will you share your screen?
Right.
Fortunately, I think this should not be insecure because it won't show us what you're typing. So we should be okay here.
Because my unique name have double A here. I don't know.
I'm pretty sure I created your account with that. Let me double check real quick. Oops, amount MVs. Yeah, I'm pretty sure I created your account with 2 A's.
Perhaps it was a mistake that I made when I logged in.
Let me double check. Okay. Okay, so your user account has 2 A's at the end.
Thank you.
Yep. Just to double check, that is how you wanted it to be, right? Because if you'd prefer otherwise, I can create a different user account with a different name.
Thank you. I am logged in again.
Okay, perfect. Great. Then let me share again and we can move on now that everybody is connected. So now that you're into the system, we can start kind of playing around a bit with what you can actually do in here. Like I mentioned, this is a Linux system. So if this means anything to you, it's a Unix-like operating system, which means it goes back decades and decades now. There are a ton of different Linux distributions which tend to come in different flavors of what the graphical side looks like, a little bit of what the under the hood stuff looks like. I tend to use Ubuntu-based systems because I like the way that their graphical desktop works, and I like how they handle package installation and stuff under the hood. For the most part, you're going to be interacting with the system through command line tools. So this is where when you're working with the system and you're in the terminal, you're going to type a command and some arguments to pass to the command, then hit enter, and it's going to do it. So this is somewhat old-fashioned, but it can also be nice because when you're working with command line tools, you can also chain them together in scripts. You can, there are some things that are just really fast to do with command line tools that would take longer to do through the user interface. Like creating user accounts for me is actually very fast to do through command line tools, where I'd have to click around a ton to actually make a user account in the graphical user interface. We'll talk a bit more about how to actually enter commands, but generally speaking, a Linux command is going to look kind of like this. You'll have the name of the command, you'll have keyword arguments to pass to the command, and I'll show you what those look like for Linux commands, and then any other argument that the thing needs. So this could be the name of a file, or if you're making a user account, the user's name. One thing that I think is worth taking a look at, because this is maybe unfamiliar, but also I think is not obvious when you immediately log into the system, is the kind of the file system structure of a Linux computer. So, if you're working in a Windows machine, you're used to kind of like the C drive, and then there's folders in the C drive, and one of the folders is the user folder, and in that is your user folder, and then you have documents and stuff. Linux isn't so different from that, but it does name things a little bit differently, and that, I think, means that it takes a little bit of getting used to. So here is, I'm going to put this in present mode so it's a little bigger. So this is what the directory structure of a Linux computer looks like. It's basically a tree, and the very deepest part of the tree is the root directory. So this is just the trunk from which every other folder kind of is descended. It's like a genealogy in some sense. So Linux and Unix-like systems, so Macs also use the / character as your directory delineator. So if you happen to be in your home directory, which you'll probably spend a certain amount of time in, you'll be in /home / your username. These other directories are just for different sorts of storage. So /bin is where the compiled binary files for a lot of programs live. /etc is where a lot of utilities are. /media would be if you plug in a USB drive, it'll show up as /media /USB drive. The other one that might be important is /mount, MNT. This is where like external hard drives or new hard drives show up. And this one's kind of important for these systems because the T-Core systems have their hard drives set up in what's called RAID, which is just a system that enables the hard drives to tolerate some failure. So basically I have a pair of hard drives working in sequence or working in concert with data duplicated across those hard drives. So if you have a file on one hard drive, there's a duplicate copy of that file on the other hard drive, which means if one of those two hard drives breaks, it corrupts or it catches fire or something, your data isn't actually lost because that other hard drive has a copy, and I can pull out the broken hard drive, put a new one in, and everything will keep working. So one thing that you may notice as you're kind of navigating around the systems is that your home folder is actually stored in the mount partition. So your home folders are actually here. So right now I'm in the directory /mount /md0, which is the RAID system for this computer, and you can see all of the user home folders for people who I've made accounts on this system. I'm not going to look in them, but just know that. So when you're navigating around the system, if I want to go to my home, then that directory would be / so root home, that would be my home directory. Alternatively, because of this system's architecture, it would be / mnt md0 that. And terminal systems have some features that are actually kind of convenient. It seems like it would be very, very tedious to type your way through the system, but one of the things that that basically every shell has that is super helpful is a thing called tab completion. So if you start typing a directory name and you hit tab, the system will try to autocomplete it for you. So if I want to go to Jioon's home folder, for example, and I want to go to mount, I'll start typing mount and hit tab, and then I'll start typing md0 and hit tab, and then start typing her username and hit tab, and the rest will fill in. Obviously, this works best if what you're typing has only one match within the folder that you're looking in. Like if I were just to do this, the autocomplete doesn't really know what to do, and it'll tell me, look, there's two things that start with J, which one do you want? So I'll start typing a little more, hit tab, and it autocompletes. And this makes navigating the system vastly faster by the terminal, as long as you have a sense for what the folders are named. Yes?
I have one question. So you have like this all folders kind of duplicated into one like a home, and then the other is a MNT MD0. So could you say that again? Like what's the difference here?
Okay, so normally on a Linux system, your home folder, so the default directory that you log into would be stored in root home, so / home. And that would be stored on whatever hard drive the operating system is installed on. So on these computers, I've installed the operating system and the storage on different hard drives. So I think this might be a little bit of unnecessary detail, but I think
maybe then we
having
can, maybe then we can just talk later.
Well, no, I think this is helpful actually, because I think it's helpful to have some idea of what the computer you're working with looks like. So you're going to get one of my fine high quality MS Paint drawings to diagram this. So here's the computer. Ooh, that's, wow, okay, nice, great. This computer, basically, the way I would think about it is that it has two hard drives. There's one hard drive, which is an SSD, and this hard drive is where the operating system is installed. And this also means that this is where root and home, bin, all of those folders that are part of the Linux file system, these are also by default stored here. However, I've also got this extra set of hard drives, which are just regular spinning hard drives. They're arranged in a RAID array that I've named MD0. And this is where, so none of the default Linux directories are linked to this. But what I've done when I created user accounts was I created a link between home and MD0. So when you go to home, what that's actually doing is redirecting you to mount MD0 name. So your home folder is actually stored on MD0, so this array of drives, but it's linked in the regular directory structure so that to go home, you don't have to explicitly go to mount MD0 your username. You can just go home your username. And that's what's happening here.
So then what is the reason like you are having this directory?
So the reason I built the system this way is because a solid state drive is fast, and it will load the operating system, and it'll load programs, and it'll run programs way faster than a spinning hard drive, a regular actual disk. But solid state drives do not have the capacity that regular hard drives do, or they don't without spending an arm and a leg on them. So what I've tried to do here is balance the performance of the system with its storage capacity. And that's why all the home folders are in these in this RAID system made up of regular hard drives, which has a total capacity of about 8 terabytes, where this SSD that the operating system stored on only has about 256 gigabytes. So it has way less storage, but it's vastly faster. And because we're not storing most of our data on that SSD, it's fine, and it's not likely to ever hit capacity. So our actual files are getting stored on MD0, the RAID system, just so that we can take advantage of the fact that it costs a fraction of the amount to add terabytes of storage to that system as it would to add to an SSD system. So like a terabyte SSD costs about $130. A terabyte spinning hard drive is like 50, if that. So
okay, great.
So that was sort of my trade-off. Yeah.
Oh,
the other reason, and this is actually something that I tend to recommend in computer builds in general, is that I do not like my operating system and my storage partition to be on the same drive. And the reason for that is that, especially on Windows computers, if something tries to write to a file that the operating system uses, your system gets messed up really bad. And so I tend to like to kind of keep the operating system walled off a little bit from storage and other programs and things, especially on Windows computers. So basically any Windows computer I build for myself has a solid state drive where the operating system lives, where just Windows lives. And then it'll have a second drive where I install programs to and that I use for storage. So that in general, it's very hard for that drive and for stuff working with that drive to write to the operating system drive and corrupt something. So it just kind of keeps my systems a little safer and less prone to exploding because something wrote to a place it wasn't supposed to.
Yeah, I think this is really clever. Thank you.
So I'm going to go back then to my slide deck and stuff. And I'm always happy to talk about computers and building computers and stuff. So anytime anybody ever wants to do that, I'll be more than happy to. Like I said, this is something I like to do as a hobby, so it's great to actually have a part of research work and to have interest. So this slide, I don't think I need to go into in great detail, but this is just a longer description of what some of those folders actually contain. If you're curious about, like, you know, if you're Googling around for Linux stuff, often things will be like, well, go to /bin//bash/ whatever, /etc/ I don't know, hosts or whatever. And that can be rather mysterious if you don't have a sense for what those folders tend to generally contain. So this is just a reference really for what things are likely to hold if you know, if something asks you to go to /etc/whatever. So now that we have taken a look at what the file system looks like, and the main thing that I would reinforce is that the file system of these computers, and pretty much of every computer, is basically a tree. So you navigate it by moving across branches. And if you're using a graphical operating system, you can kind of skip around a lot. But in terminal operating systems, it's not as obvious how to do that because it feels more constrained in some ways. It's not in practice, but I think it just takes some getting used to operating in a bit of a different way than a lot of us, I think, have gotten used to. I mean, even I grew up mostly on graphical operating systems, so there's a bit of a shift there going back. So I'm going to spend a little bit of time going through how to navigate a Linux system through the terminal. When you log in by default, you will start in your home directory. So the directory specified by /home/your unique name. And as June and I were talking about, this is a link to your home folder that's stored on the actual big spinning hard drives of this system. There's a convenient shorthand for being at home on a system, which is this ~/. So what you'll often see is if I'm in my home directory, you'll see this little tilde, and that just means that I'm in my home directory there. Where when I was in Mount MD0, that wasn't there. Like, you could see the directory that I was in. So one thing to keep in mind is that the Linux terminal is showing you where you are in the file system at any given point. So that'll help you to know, oh, I'm here and I need to go here. If you lose track of where you are, then you can use the pwd command, which stands for print working directory. So I'll demonstrate that here. Pwd enter. And it's telling me, oh, I'm in home and me, om hayash. If I was somewhere else in the system, like bin, and I did that, then I'd be there. And this might seem a tiny bit stupid because, well, I just went there and I presumably knew where I was. But when you have project folders that have like 3 layers deep, and you have like 2020-06-13 /data/runs/run1, then sometimes it can be helpful to know what your full working directory path is. So then to actually navigate around the system, you'll want to use the cd command, which is short for change directory. And this command actually, so these commands are ones which will also work in Mac terminals, and a lot of them will also work in PowerShell, but not the regular command prompt for Windows. Windows command prompt has its own deeply unintuitive names for changing directories, but you can cd in PowerShell, which I think is quite nice. So if you cd with no arguments, by default what this is going to do is return you to your home directory. So I'll demonstrate that here. I'm in bin right now, and if I type cd, I go home. And now I can confirm that I'm home. So that's nice. And that's often really convenient to just kind of immediately reset yourself back to your home directory. If you cd to a relative directory, then you'll move to that directory. And I'll talk a bit about relative versus absolute directories, but suppose I'm home and I have some folders in home and I want to go to my documents. So if I do cd documents, I will be moved to documents. And I made a typo here, so this should be cd / relative directory. So the dot indicates that you're moving to a relative file path, and again, I'll repeat this in a bit. A relative directory has to be accessible from your current directory. So it has to be somewhere down the tree from where you are currently. If I were to go to, if I were to go back to bin, or I'm not going to go to bin, that's dangerous. I shouldn't be working in that folder at all. We'll go to mount md0. So if I'm here and I try to go to documents, that's not going to work because there is no such file, there's no such folder called documents in mount md0 because that folder is only a folder of my home directory, so I had to access it in that way. So if I go home and then cd /documents, now I can move to documents and I can confirm that I'm there. And this is my, and when you type print working directory, this will show you the full absolute file path to wherever you happen to be, which is quite nice because often you'll need that when you're doing analysis and you need to load a data file from somewhere. You can also change directory to an absolute directory. So if I'm in my documents folder and I want to go to mount md0, I can do cd mount md0, and it just jumps me from my documents folder all the way across the tree over to mount md0. So this is stuff I would just kind of play around with, wander around the system, go to different folders, things like that. Confirm that you can kind of navigate through your own user directory, things like that. One other thing that's handy about change directory, so there's one other feature that I tend to use is if you type cd ... this will move you up exactly one level in the file tree. So now I've gone from my working directory, I'll go home again. So I'm in home, my username. If I type cd ... it's moved me up a level, and we can see here that it's moved me to home. And we can confirm that, which means that now I'm in root home or /home. This is one I use this a ton because often if I'm like really deep in a folder tree because I'm looking at a data file or something, I'll just want to go one level up to use something there or something like that. So it's convenient shorthand. I'm going to go home again. And I'm going to skip absolute and relative paths for a moment because one thing that that might be useful is to know what's actually in a folder. And I put this in a later slide, but I'm going to kind of preview it here. So the command ls or list will show you what's in the folder you're currently in without any other arguments. So if I'm in my home folder and I type ls, you can see that I have a folder called Anaconda 2, and I have a folder called Documents, Music, Public, Templates, Desktop, down. So since I'm in my home folder, I have all the folders that you might kind of assume that a person would have in their home folder. This looks a lot like your Windows system or your Mac system where you have all your regular things. So basically, the combination of CD and LS are how you're going to navigate this system. CD to move around, LS to make sure that you know what's in the folder, sometimes PWD to make sure you're in the folder that you think you wanted to go to. And I'll talk a bit more about how to use LS in some more interesting ways in a bit. So really quick, when you're navigating a file system like that, and when you're running an analysis that relies on being somewhere in a file system or loading a data file from somewhere, it's important to keep track of whether you're referencing something by an absolute path or a relative path. So an absolute path is telling you the full path to a location from root. So this is like if I told you how to get from I don't know, if I was navigating somewhere and I wanted to tell someone how to get from my home to work, I would start from my home address. I'd say turn left at Green, right on Hubbard, maybe left on Washtenaw, and so on until I get to work. And in the computer sense, this means that every absolute path has to start at root. So you're going to start at /, then it's going to tell you whatever the next directory is, the next directory after that, and so on. Again, following whatever file structure you need. For the most part, I think for a lot of your analysis, this is going to look like root /home or /home / your username / some folder in your username / a subfolder of that folder / sub subfolder and so on. And absolute paths, I tend to prefer if I'm trying to load a data file from somewhere. So if I've stored a data file in some really deep subfolder structure, I'll usually access it by an absolute path. A relative path is a directory path relative to your current location. So again, if I'm giving directions to someone and I know that they're already, say, at the intersection of Plymouth and Huron, I'm not going to start those directions back from my apartment. I'm going to start from Plymouth and Huron and say, turn left on Huron, turn right on whatever, and keep going. And the same thing applies to a relative path on a computer. So if I'm in my home directory, and as I demonstrated, if I want to go to, say, documents in some subfolder of documents, I'm going to start this with // and this // just tells the system go relative to this place, relative to wherever you are currently, your current working directory. And then I had better hope that documents is a folder within my home directory and that projects is a folder within documents. And that's, so one thing just to be careful of is if you use relative paths a lot when you're storing files and accessing files, just be very careful about what your current working directory is. And this is something that in R and things, if you're working with Rstudio, you often have to set your working directory to some location. And exactly the same thing applies when you're working with the file system of these computers. So a little bit more then about actually working with files on the system. I kind of previewed the list command, ls. If you don't pass list any arguments, it'll just show you kind of a short version of everything that's in your current directory. It'll list their names and that's it. But as I mentioned before, Linux commands accept arguments. Usually, a lot of Linux commands accept arguments in the form of just a letter that abbreviates what that argument does and preceded by a dash. So if I say ls-a, this is going to show me everything including hidden folders and files, which is kind of nice. So ls-a, you can see that there's now a bunch of these extra folders that that have a start with a dot. Basically, this is the equivalent of Windows systems and Mac systems also hide some folders from the user by default because they contain stuff that they consider dangerous for the user to fiddle with. Same thing with Linux machines. So there's all these extra little folders here that I may need to access, like bash rc is one that I often need to deal with. And so ls-a, that a argument is show all, basically. Another argument you might find useful is ls-l. So this is list in long format. So ls-l. And what now has happened is it's giving me a verbose description of each thing in my current directory. So instead of just telling me the name, now it's telling me the permissions for that thing. So can I read, can I write, can I execute stuff? Who owns it? When it was modified and things like that. The things that are often most useful here are when a thing was modified and what the permissions are, because some things by default may not have, say, execute permission, which means that if it's a program, you may not actually be able to run it. Some things have limited read-write permissions depending on the user. So ls-l is super helpful if you need to double check, oh, I do indeed own this file, and here's when it was created and all of that stuff. You can give a Linux command multiple arguments. So if I wanted to have long format output for all files and folders in my directory, I could do ls-la, and now it's shown me, even for these hidden folders and files that start with a dot, full information about them. So permissions, ownership. I think this is size, but I can't, size in bytes maybe, but I'd need to look that up. And then the last time the thing was modified. So this format of dash and then single letter arguments kind of smushed together, this works for most Linux commands and Unix commands. And if you want to know what kind of commands are available for a thing, and if you want to know information about a command, you can type man, say ls, man short for manual, and you should get a little plain text manual describing what the thing does and how it's used. what arguments it will accept. So -A, -B, -C, and so on. Linux commands and Unix commands will usually accept arguments in one of two formats. The short one is the -single letter. There's a longer format that's ~word. And whether you use one or the other depends on basically what you're used to and what you find more convenient. So instead of ls-a, I could have said ls-all. I can demonstrate that here. ls-all does the same thing as ls-a. A few other quick navigation things. If I'm in, say, in man, if I'm looking at a manual and I want to leave it, I can type Q to quit. If you need to halt the execution of something on a Linux system or a Mac, and then actually I think Windows 2, you press Control-C, and that will kill whatever happens to be running at the moment in the terminal. Specifically, it'll halt a thing which is actively executing, not something that you've pushed to the background, which we can talk about a little bit later. Okay, so that's ls. You can chain arguments. You may find it useful to copy and or move files around. So cp is the copy command. Your usual usage is cp the source file or directory and then the target. So if I create a file that's like, and I type something in that. So I now have this file called temp.txt. Suppose I want to put that in my documents. Now I could do something like copy temp.txt to there. And notice that what I've done here is, for one, if I'm saying copy temp.txt, what I'm assuming is that temp.txt exists in my home folder. If it doesn't, then I would need to specify its file path. Like I could do something like home that. I could give it an absolute path to the file. I generally recommend doing this unless you're very confident that the file that you want to work with is indeed in your working directory. And then notice that here I've done the shorthand of relative path to documents. So I can now list documents, and I've moved temp.txt into documents, but it's still in my home folder, so I've just copied it, and that's fine. You can also copy and change name at the same time. So if I look at documents now, you can see that I've made an extra little thing called temp1. So when you're working with Linux commands that work with a file or a directory, in those cases, you'll want to make sure that you're either giving the full file path, the absolute path to the file, or the relative path to the file if you're confident in where you're sitting within the system. If I just want to move a file without copying it, like if I accidentally created temp.txt in home and I in fact wanted it to be in documents, I could use the move command. So this command is neat because it will let me do two things. I can either move a file or I could rename a file. So suppose I created temp.txt, but that's kind of a stupid name and I want to call it, I don't know, hello.txt. What I can say is move the source file to the new source file name. So I'm just going to do move temp.txt. And here I can also exploit tab autocomplete to save me some typing. And I want to change this to hello.txt. So here's the source file with a relative file path. So from my home to also still in home, but just a different name. And now, if I list the contents of my home directory, you can see that there's no longer temp.txt, but there's now hello.txt, which is exactly the same file. So that's kind of cool. I can also, of course, use move to do what you might expect it to, which is move that file to a different folder. So let's suppose I don't want hello.txt in home and I want it in documents. I'm going to say move hello.txt to documents, and I'm not going to change its name. So it's just going to move in there. And now if I list the contents of documents, you can see that hello.txt lives there, but not in my home folder anymore, or not in the top level of my home folder. So that's quite nice. Both of these commands do have some more sophisticated usage as well that'll let you apply the same thing for like an entire folder or many files. But right now I figure I'll just kind of go over simple uses, and there's always Google and Stack Exchange for more sophisticated uses. And then, of course, if you create a file that you don't want, you can use the rm command remove to delete that file. So the usage here is rm and then the file. So if I want to clean up my documents, I'm going to go to Documents. There's hello, there's temp, and there's temp, and I don't want either of those. So let's remove temp1.txt, and now it's gone. I can remove temp.txt, and it's gone. And remove is a little bit of a dangerous command, so be careful with this because it's not going to ask you to confirm, and it's just going to do what you told it to. So Linux systems, in some ways, working through the terminal are they're the very embodiment of the phenomenon where a computer will do exactly what you tell it to and nothing else. And this can be dangerous for humans that sometimes expect things to interpret what they told it. A computer doesn't do that. If you tell it to remove this file, it's going to remove that file, and that file is gone. And there are other uses for remove, like there are other arguments like force, which will delete a file which is open or which is being used by something. You can delete entire folders. You can delete the contents of entire folders using other arguments. I haven't shown those here because frankly, those are quite dangerous, and those are good ways to accidentally delete a system folder or something. And none of you should have the privileges on the system to be able to do that, but it's just kind of safer to not in general, because the terminal interface doesn't provide like a second step of, are you sure you want to do this? No, it's just going to do the thing that you told it to, and you have to kind of hope that that thing was what was correct. There is one other kind of subtle feature to working, especially with the Chrome SSH client. I don't know if it's been showing this, but when I select something, the Chrome SSH client automatically copies whatever I've selected, which can be kind of convenient if you need to like copy a path and paste it into a text file somewhere else. But one thing that is nice on a Linux system is if you press the middle mouse button, it will paste whatever is in your clipboard or whatever you've most recently copied into the Linux system. So let's suppose that I'm going to write something in a random text file out here. I'm going to write some command that's like cd some directory. I'm going to copy that thing, and then I'm going to hit middle mouse to copy that into the terminal window. And this should work regardless of which SSH client you're using. So instead of having to type that whole command, and this is especially good if you've Googled a command through like Stack Exchange or something, and it's this big long command, you can select it, copy it, and then middle mouse click to paste. And suddenly you get that whole command. So that is why in a lot of cases, if you're looking at an answer on Stack Exchange or in documentation, it'll be like run this command. And if you're like, well, this command is gigantic and I'm going to get it wrong typing, you can just copy paste it into the terminal. However, Control-C, Control-V generally will not work in terminal because Control-V is not defined as a paste command. So just that is something to keep in mind. Similarly, in Linux terminals, generally speaking, selecting something is sufficient to copy it. So if you just kind of mouse select something and then middle mouse click, I've now pasted that line above. So that also is a little bit different from working with like graphical operating system components. All right, so let's keep moving. For the most part, we're likely to be working with remote files. So it's probably the case that you want to get a file from your computer onto one of the CAsToR systems or one of the CAsToR systems. And for what we've seen so far is how to manage files that are already local to one of the systems. There's a couple of tools that you can use to transfer files between your system and the remote system. One of them is called the Secure File Transfer Protocol, or SFTP. This is just, this is a thing that uses SSH to give you the ability to manipulate files on some remote system. Depending on your system, you can use command line tools to do SFTP or like a graphical program. Personally, I've been using one called CyberDuck lately because it's available for Linux, Mac, and Windows, and it has some kind of cool features that I can demo at the end if anyone's interested. FileZilla is another SFTP client program. WinSCP is one that I used for a while. Bitvice also. And these are nice. They basically let you kind of copy folders and files between systems. You can manipulate the file structure on the remote system or on your local system. You can specify which directory you want to remote into to work with. There's a simpler command called SCP, or Secure Copy Protocol, and this basically works like the CP command, except for a remote system. So if you want to copy a file to a remote system from your local system, you can enter the command scp and then the source file directory, and then you'll want to say where you're sending it, so your username at your host address, colon, the target file. If you want to copy from remote to your local system, you can say scp your username at host address. So this is the remote system that you want to access, and then the file, colon, the file directory, and then space, the target file on your local system or where you want to send it. So the syntax here is exactly like the copy syntax, except it has this extra little thing to tell you what the remote system is. I'm not actually going to spend an enormous amount of time here because I think by and large, I suspect that most people will be accessing this system through Rstudio server. And if you're doing that, it has built-in file management and built-in remote file management. So if you're curious about SCP usage and stuff because you want to write a shell script or something, I'm happy to talk about that at some point. But otherwise, I would largely, I think I'd rather spend a little bit of time looking at Rstudio. So SCP also accepts different arguments like -R, which enables recursive mode, so you can copy the entire contents of a folder. With all of these file manipulation things, they also allow you to use some kind of special characters and regular expressions. So if I had a ton of, say, text files, if I wanted to do something like remove all things with, so remove everything that's a .txt, I can use this wildcard character, the star, and this is going to delete everything with a .txt file extension. So of course, be careful with this because the system will not ask for confirmation before it does this. It'll just, oops, well, fortunately I don't have anything here, but if I was in, if I wanted to do that from documents, it'll do it and it won't ask me to confirm anything. And now there's nothing in documents because I deleted every text file in there. So, oops, moving on a little bit, there are some other command line tools which are helpful and can be extremely powerful. grep is common, and you'll see this in a ton of Stack Exchange answers and things like that. What grep does is it searches for particular text patterns within a file. So one thing to keep in mind, I think, is that basically at some level, everything on a computer is a file somewhere. It might be a binary file that's ones and zeros, but a lot of things are text files. And I mean, scripts are text files, your data are stored as text files. And so if you need to know whether, say, a name is in a text file, you can say grep my name in that text file, or grep the name that you want in that file. You can also use the word count command, WC, to ask for the number of lines in a file, the total number of words, and the total number of characters. This is great to verify that the data that you've transferred is indeed what you want. Like if you transfer a data file that you know is 1,500 lines long, you can word count it, make sure that there's 1,500 lines in it, and you didn't lose anything in transfer. You can use commands like head and tail to show the first and last several lines of a file. This is also, a lot of these are good for just verifying that files that you transferred made it through okay and shows stuff that you want them to. You can create folders through the command line, so make dir, mkdir. So let's suppose that I'm in documents and I want to make a folder called projects. I'm going to make that. And now I have a new folder called projects that I can navigate to and look in. There's nothing there right now, but that's fine. A couple of other kind of fun things. This vertical bar, which is above the backslash on your keyboard, this is called a pipe. And if you use a pipe, then this is going to take the output of the first command and send it to a second command. It may not be entirely obvious why you'd want to do that, but if you're writing scripts for the shell, this can be cool because if you're like, I want to search for a particular pattern in a file and then send that pattern to another command, you can do that with the pipe. The caret here is a redirect, so you can redirect the output of some command to a file. So this is nice if you want to redirect like output of an analysis to some file. If I had 2 carets, this is going to output and append. So by default, 1 caret outputs and overwrites, 2 carets outputs and appends. So this is, I'll use this a lot if I'm trying to, oops, I lost that. There we go. So 1 caret is overwrite, 2 carets is append. I'll use this if I want to debug basically, or if I need to store output that I've printed to console to some file to look at later. So the old-fashioned way, and frankly the way that I run most scripts on a system, is through command line commands. So if you want to run an R script on tcors 1, for example, what you can do is use the command rscript, pass it some options, give it your script name, and then pass it some arguments to pass to that script. So suppose I wanted to do R script test.r. If I had written a script called test.r, this would run that script. Similarly, if you happen to write Python scripts, then you can do the same thing with the Python interpreter. So these systems should all have a default system Python distribution. And if I wanted to run a Python script, I'd do Python testscript.py and then hit enter and it would run this. One thing that can be useful when you're working remotely is this thing called NoHup, which is short for no hangup. So if you're running a script and it takes a while to run, and you've run it through the command line, and you close this SSH connection, it's actually going to stop that script because closing the terminal connection is going to halt all processes that are running in the terminal. You don't want that if your script takes a while to run. You usually want that script to keep going when you leave so you don't have to stay connected to the system. So if you use nohup with your command and then end it with an and or an ampersand, this is going to tell the system, don't stop this command when I close the SSH connection and run it in the background. So all of this together means that that script is just going to keep running in the background until it's finished, regardless of whether you close the SSH connection or whether it gets killed by bad internet or something like that. So if you want to run a really lengthy model analysis or a really long data analysis, you'll usually, and you're doing it through console, you'll usually want to use nohup and run it as a background process. And by default, any output that this script generates is going to be sent to a file called nohup.out, which is stored in the working directory that you ran the script from. And this lets you debug, like sometimes it'll tell you, oh, there was an error and it failed, or it'll just catch any output that this script is printing. So I'm going to kind of move past that for the sake of time and spend a little bit more time talking about using Rstudio server for this last 20 minutes of the workshop. So most folks, I think, will be familiar with working with Rstudio Desktop. It's kind of an integrated development environment for R that lets you write scripts and run them and do data analysis and all of that stuff. Rstudio server is that, but it's running the actual Rstudio instance on, say, tcors 1. And when you access it, you're running all of your stuff on tcors 1, which is cool because tcors 1 is huge and way more powerful than any computer that you might possibly have direct access to. I think I can about guarantee that. These things are really big for workstations. So RStudio server is installed on all 3 of the UMT core systems. So when you log into any one of those, you should be able to log in through RStudio server. The thing that I find kind of magical is that RStudio server comes with what's called a browser client. So you can access it through Chrome or Firefox or Safari or Edge if for some reason you're using that. It does require the VPN connection. So you have to have the U of M VPN client connected to the U of M network because it's communicating over a port which requires a firewall exemption, basically, and then therefore also needs the rest of the security infrastructure. So if you don't already have the U of M VPN client, what I would recommend you do is go to this link and download the client for your system and set it up per the instructions. I'm going to assume for now that you have the VPN client or happen to be on campus right now. So I'm going to move on from that. To log in a browser, you'll want to go to the address of the machine, :8787. 8787 is just the port that this is communicating on. So for example, for all of us who have accounts on UMT Cores 01, here's what you'd literally paste into your browser window. So you can see here that where I'd normally have like www.google.com, instead I have the address of the machine with :8787. And that has taken me to this little login page, which is a login page for the RStudio server instance on T-Cores 01, which is kind of cool. I think it's cool at least. So this is, once you've logged in, it'll show you this. You can now enter on this page your system username and your password. So this is your unique name, in my case, this, and my password. And when I click sign in, it's going to put me into an RStudio instance, which looks basically identical to desktop RStudio. So here's your interface, and I'll pause for a moment so folks can give this a go. Make sure, of course, that you type the address exactly as specified here, umtcores01.ddns.sph.umich.edu, :8787. And if you're connected to the VPN right now, or you're on a campus network, this should work. So what I think is quite handy about this is, for one, this interface is just, it's an RStudio interface. So if you've used RStudio Desktop, you'll almost certainly know how to work with this. There's a bit of extra stuff that's nice. I mentioned that there's a file manager. So in this pane on the right down here, you can see like files in addition to plots, packages, help, and so on. What files lets you do is you'll notice that it's telling me that I'm in my home directory on T-Cores 1. And so it's shown me all the folders and all the files that are in my home directory. If I want to, say, upload a file, I can click upload and choose a file from my local system. So so I could pick a file from my actual local system and upload it to T-Cores 1 in my home directory, which means that you don't even need an SCP command or an SFTP client to do that. You can just work completely through this client interface, which I think is awfully cool. You can also, if you go to more, you can click more and then you can export a file. So if for some reason I wanted to if I wanted to export a file, I could go to, I don't think I actually have any files, but if for some reason I wanted to export this thing, I could go to more and click export, and my desktop that I'm sitting at right now would download that file from T-Cores 1, and now I have that file on my desktop. So this in total lets you do basically all the stuff that you'd want to do to get your data files or your scripts onto T-Cores 1, run them, and then get your data back from that. You can, of course, still use SCP and all of that stuff to do that, but this is a nice alternative option. Packages in RStudio server are per user. So if I install packages in my user space, suppose I want to install desolve, which I haven't installed, and you can tell that I don't use R because if I did, this would have been installed already. When I install it, it's going to put it in my own special user library. So for one, what I can do is install packages even though, well, you can install packages even though you're not admin users. And I can install packages without impacting anybody else's R installation and their package library. So that's neat. You have file management. There's also, so RStudio server, it can be kind of a one-stop shop. So you can use this basically instead of any of the other remote connection stuff that we've done. I went through that and I pulled some teeth going through that because I think it's helpful to know how to do, but you can use RStudio server instead. RStudio server has a terminal instance built in. So if I click this terminal tab, it takes me to an actual terminal instance. You can see that I was debugging something of Pien's previously, or taking a look at files and stuff. But this is exactly the same system terminal that you would get through through SSH or something like that. Sometimes there's a little bit of the terminal doesn't always just work. Sometimes you have to go to Tools, Global Options, and then in terminal, I think there occasionally are some options that you need to check or uncheck. If you have trouble accessing a terminal through RStudio server, I wrote some documentation at some point that solved some problems with that. I can dig that up and sort that out. Another feature of RStudio server that I actually had not noticed before, and I think this is a new version thing, is this Jobs tab. So there's not a whole lot obvious, but what you can do here is you can click Start Local Job, give it a script and a working directory, and then you can run that script in the background from RStudio server. This is basically a cluster scheduling system. So if I have a script that I want to run, instead of running it using the rscript command at the terminal, I can just upload that script here and tell it what working directory to be in, and then click start, and that script is just going to run in the background and it's going to go until it's done, which is pretty cool. And this feature I hadn't actually noticed until I logged in again this weekend to put this demo together. One thing also that's nice about the RStudio server instance is you can start running something in an instance and then log out and it'll keep running. So logging out, closing your instance is not actually going to stop that thing. I can of course make new scripts as I would have. So if I wrote a script that's, I don't know, I'm not actually sure that this is going to work because I, again, don't use R very much, or I don't remember it very well. So if I make a script that's like hello.r, and then I want to let us run that script. There it is. So I've used the job scheduler to run my hello.r script, and it succeeded. Here's the timestamp, and here's what that script did. I think that's kind of magical. Maybe that's not deeply exciting to anyone else, but I think that's pretty cool. So I guess I kind of ran through the demo while I was doing this, but basically the idea is that treat this as though it's your RStudio desktop instance with extra power, like the ability to schedule a job on this system and the ability to transfer files to and from the system. One thing that I'm going to touch on quickly, and I'm going to skip through the rest so I can maybe take some questions in the last 5 or 10 minutes here. I mentioned that these systems have a lot of cores. And one thing that I think is worth keeping in mind is that unless you explicitly write your program to take advantage of them, by default, what an R script is going to do and what a data analysis in R is going to do is execute your program in a sequential way. So in your script, when you have your lines of code that do whatever, when the computer runs that program, it runs those lines in sequence in order, one at a time. And it, oops. And so all that's doing is running on a single core. Nothing about that program is telling the computer to use more than one of its cores. So if you don't tell the system otherwise, it's literally only going to use one core to run your analysis. And obviously, that's a little bit inefficient if you know that you've got 64 or 128 cores available, or even 2 or 4. So in a lot of cases, what you want to do is figure out a way to write your program in a way that can distribute things that it's doing, or write your script in a way that can distribute things that it's doing to multiple cores on the system. So a parallel program will distribute its tasks into little processes or smaller threads and send each of those to one or more of the cores on the system. So if you have two processes, then those can be distributed to two cores, and then when those cores finish running, they'll stitch their output back together into your output data object. This is, I mean, if you're doing any kind of decently big analysis or decently big modeling project, this is almost certainly what you want to do, because you can take advantage of the fact that you have a ton of cores at your disposal. However, it is a little harder to write parallelized code. So if this is something that you want to do in your analysis, you can get in touch with me, you can get in touch with any of the other researchers who have done this, like Jiyun and Pian and folks like that, to kind of work through how you want to write parallelized code. R has a parallel package, which has some really friendly interfaces to let you write parallel scripts. Like it has basically a parallelized for loop, which will, instead of a regular for loop, which is just like, if I say print something 10 times, it's only going to send this to one core, and it's going to be like print, 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 print. If you do a parallelized for loop, it's going to split that up between your cores, and one core is going to print 3 times, another core is going to print 3 times, another core is going to print 3 times, and then it'll stitch those together. So if this is something you're interested in, I'm happy to talk about that offline, or if you want a more computing and programming focused workshop at some time in the future, I would love to do that. I have a lot of thoughts about how to write programs and how to write programs in more efficient ways that can parallelize things and all of that. So if that's of interest, then let me know, and I can put another workshop together. There are some additional resources if you want to know. This cheat sheet has a bunch of Linux commands, and I have used this all the time. I have a printout copy in my office. Basically, I have a printout copy whenever I use a Linux system. This is fantastic. This is tons and tons of commands to do many things that you could possibly want to do on a Linux system. Print it, save it, make a poster, frame it. I don't know, it's great. Here's a link to the SFTP client I use. I like this one because it will also let you edit files. Like you can edit a file through the SFTP client and it will automatically sync to the remote system, and that's super cool. I've listed some R packages that I find useful, the parallel package. This one, the SQLDF package, if you know how to write SQL queries and you use the SQLDF package, you will never have to do an R merge again. I've actually never performed an R merge using R, because I use SQLDF and I use SQL joins, and so I save myself an enormous amount of hassle trying to do R merges, which are some of the most terrible things I've ever seen. Lubridate makes working with dates a bit less painful. String R lets you do regular expressions. And one thing that's on the horizon, I'd started working on this, but then COVID got in the way and I didn't have a chance to finish configuring it. We have a network attached storage that has about 16 terabytes of storage space. Might have 32 actually, I'll have to check. But eventually this will be an accessible file server that you can mount to any of the CAsToR devices and save your data to. So if you're working with gigantic data sets, at some point in the future, you'll want to be saving them to this network attached storage system. So we are coming up on 1 o'clock, so I think I'll use this time if anyone has any last minute questions or any feedback or anything that you might want to see later on. I'm happy to take that now. I would like to really quick, this stuff has been supported by the CAsToR, or the TCOR's DAD component of the grant, and that is just the best thing in the world to me, that there is a funding source to be able to pay for big ridiculous computers like that and pay me to build them. So a massive shout out and thank you to that program.
Michael, thank you so much. This is really great. And then I really think that this was a great introduction to the Linux, and it was very helpful. And I have a really quick 2 questions about the Rstudio server. So the one is that, So when you want to run some R script in the R Studios using RStudio server in the TCourse machine, the first you have to upload the file into the TCourse directory, right?
Right.
Okay, so that was the first question. So basically, you cannot run your the file in your local machine through this.
I don't believe so. It could be that that ends up being a thing that is added as a feature, but as far as I know, you have to upload your script to the TCourse machine.
Okay. And then the second question is that, so the R Studio here is that so there's only one version that everyone is going to use, right? Which means that
sorta. So multiple users can be logged in at the same time. The server instance will create a client instance for every user that's logged in. So if you log in right now, you can, and you're in a separate instance from me. If David or Thuy or Evelyn is logged in right now, they're in their own separate instance, which is not interacting with my instance in any way. So anything I do in my instance is totally compartmentalized from any other instance.
Oh, that's good to know. Actually, that was not my question.
Yes.
It was good to know. Okay, so my question is that, so when we have like RStudio on each own's machine, we have like different like version. And then periodically I have to update the version to get the new packages or new programs, I mean, new features. So my question is that, so this RStudio in the CAsToR server, is it gonna be like only one single version and then someone like is gonna upgrade or like update periodically or?
So the underlying R version on each of the TCore's machines, they are actually separate between TCore's machines because those machines aren't formed in a cluster right now. So basically I manually go through and keep them updated to make sure that the R versions are the same across them. The packages are per user and per user per machine. So if you're on TCore's 1 and you've installed a certain set of packages, those packages are only available on TCore's 1 for you. If you want those packages on TCore's 3, then you do actually have to go and install those packages for yourself again on TCore's 3. And the user is responsible for keeping their packages updated, where I'm responsible for keeping the underlying R distribution updated.
Okay, got it. Okay, thank you. And then I don't know, for future, I really like your suggestion that you would give more workshops later on the different topics. For instance, like a parallel would be one good topic, I think.
Yeah, I would love to do a parallel computing workshop at some point. I think that's something I've wanted to do for a very long time.
Yeah, that would be great. Okay, so anyone else? Do you guys have any questions?
I just think this was very helpful. Thank you. And I would second the, the feeling that, a coding, workshop where we do parallel computing, that'll be great. I'll definitely will take that.
Okay, I'll see if we can get something scheduled for that. And just really quick, did anyone have any massive trouble? Has anyone tried out the RStudio server instance for themselves, and did anyone have any huge trouble with that, or did it work?
It worked for me.
Fantastic.
Yeah, worked for me too.
All right, well, if anyone does have any other questions, yes, I will share the slides. Katie, actually, if you don't mind, I might send them to you to distribute out, and we can make those available.
That sounds great. I'm happy to help.
Fantastic. All right, well, thank you everyone for attending, and if you have any other questions, then I'm happy to chat offline. Also, just to put this out here, I am technically on staff now as a research specialist, and one of the things that I wanted to kind of offer as a service in addition to maintaining these systems is I do build computers, and I do and I can help people determine what kind of computers they might want. If you have a student, if you yourself need to get a desktop or something, I can talk to you about like what sort of needs do you have and what sort of hardware would fulfill those needs. So I'm always happy to try and help out with that.
Oh, that's very kind and nice. Thank you.
All right, well, thank you everyone, and I will let you get on with your day. I think I'm gonna get some lunch myself, and I will talk to you all later.
Thank you so much, Michael.
Thank you.
Yeah, thank you very much.